Hello students, welcome to my channel. In this video we are continuing the partial differential equations. So in this video we are going to solve that is non-linear partial differential equation in P and Q. First let us understand what is non-linear partial differential equations in P and Q. The partial differential equations in which P and Q occurs other than in the first degree is called the non-linear equations of first order. So it means that in this PDE, that is in the non-linear PDE, if the degree of P and Q is other than 1, then such a PDE is called as the non-linear PDE of first order. If degree is equals to 1, then that is known as the Lagrange's linear PDE, so which are already we have solved in the last video. So now we are going to solve the non-linear PDE in P and Q. So remember that here, that is in the non-linear PDE, the degree of the P and Q are other than 1, okay, and definitely they are of first order. Now, so in this non-linear PDE we have 4 different forms, okay. So let us see one by one. First type, the equations containing P and Q only. So here these nonlinear PDE are grouped into 4 types, okay. So type 1, so here this form contains, or this type is of the form f of P comma Q. So that means it contains only P and Q terms, okay. So now the working rule of this non-linear PDE, that is type 1 PDE, is first step, let us consider the given equation as equation 1, and next step, let the solution of this equation be z is equals to ax plus by plus z. We assume that the solution of this equation is z equals to ax plus by plus z. Definitely the value of P will be dou z by dou x equals to A, because here the solution is equals to Ax, means definitely it must contain the P terms. So therefore P is equals to dou z by dou x, which is equals to A, and Q is equals to dou z by dou y, which is equals to B. Now we substitute this value, that is P value dou z by dou x equals to A in the given equation, both A, P and Q values in the equation 1. Then the equation 1, this becomes in terms of A and B. So then we can easily find the value of B in terms of A and consider that as B is equals to phi of A. Therefore we write the complete solution as, simply we substitute this B value in the solution, that is the complete solution will be z equals to ax plus phi of A plus C. Phi of A means it is the value of B in terms of A. So solving the problems are very easy. So it contains very easy steps. Simply we remove P by A, that is we replace P by A and Q by B. Then we find the value of B in terms of A. Finally we substitute in the solution z is equals to ax plus by plus C, that is we substitute the B value in the z is equals to ax plus B plus C. So then it takes this form, that is z is equals to ax plus phi of A plus C, okay. So now we consider some examples. Solve P square plus Q square is equals to 1. Solution. So you can observe that this equation contains only P terms and Q terms of degree 2. So if it contains other than degree 1, definitely that will be non-linear, because it contains only P and Q terms, therefore it is of type 1. Now simply we solve this one, that is simply replacing P by A and Q by B. So that is, first let us the given equation as equation 1, let P square plus Q square is equals to 1 as a equation 1. Now let the solution of this equation B, Z is equals to AX plus BY plus C. Okay, now simply replace P by A and Q by B in the given equation 1. So therefore equation 1 implies that P square means it is A square plus Q square means B square equals to 1. Now we solve for B, that is we separate the B terms, that is we solve the B value or we find the B value in terms of A. So separating this B, we get B square is equals to 1 minus A square, or B is equals to square root of 1 minus A square. Now substitute this B value in the solution, or you may consider this as equation 2, then we write in 2. So therefore the complete solution is Z is equals to, keep AX as it is, in the place of B we write this value, that is 1 minus A square into Y plus C. So this is the required solution. Okay, so like this, simply replacing P by A and Q by B and finding the value of B in terms of A, we get the required solution. Okay, next problem, P square into Q cube equals to 1. So here also we follow the same steps. So that is, consider given equation as equation 1. Now let the solution of this equation is Z is equals to AX plus BY plus C. Now replace P by A and Q by B in 1. So then equation 1 implies that A square B cube equals to 1, or B cube is equals to 1 divided by A square, or B value is equals to 1 by A square to the power 1 by 3. So therefore the complete solution, we substitute this value in the equation 2. So here we consider this as equation 2. So substituting this value in equation 2. Okay. Okay. So thus the complete solution is Z is equals to AX plus B value is 1 divided by A square to the power 1 by 3 into Y plus C. So this is the required solution. Similarly, so we have one more example here. P is equals to E raised to Q. So again we follow the same procedure, that is, given equation we consider it as equation 1. Then let the solution of this equation be Z is equals to AX plus BY plus C is equals to equation 2. Now we replace P by A and Q by B in 1, so that we get A is equals to E raised to B. Okay, so that is taking antilog on both sides. So simply here we get A is equals to E raised to B, or taking antilog on both sides we get B value is equals to log A. So substitute this value in equation 2. So therefore the complete solution is z is equals to ax plus by. B means here we have log a into y plus c. Okay. Next problem. PQ equals to 1. Solution. Let z is equals to, first we write the given equation. PQ equals to 1 as a equation 1. Let solution of this equation be z is equals to ax plus by plus c. So equation 2. Now put p equals to a and q equals to b in 1. So substituting this value we get ab is equals to 1. This implies that b is equals to 1 divided by a. Put this value in equation 2. Thus the complete solution is z is equals to ax plus b is 1 by a into y plus c. So this is the required solution. Okay. Next example. B is equals to root p plus root q equals to 1. Let given equation as equation 1. Let solution of this equation be z is equals to ax plus by plus c as equation 2. Now again replace p by a and q by b in 1, so that the given equation 1 implies that root a plus root b is equals to 1. So that root b value will be 1 minus root a. Okay. So it is 1 minus root a, or else we can write it as, because root 1 can be written as root 1 also, or simply we can keep this value as it is, so that our solution will be. So further, first we simplify this b value. So solution b will be 1 minus root a whole square. So now substituting this value, put in 2. Okay. So thus the equation 2 implies that is the complete solution will be z is equals to ax plus b value is 1 minus root a whole square into y plus c. So this is the complete solution. Next we have one more example. PQ plus P plus Q is equals to 0. Let PQ plus P plus Q is equals to 0 as equation 1. Now let the solution be z is equals to ax plus by plus c as equation 2. Now replace p by a and q by p in 1. Okay. So replacing in the given equation, we get equation 1 implies that p value is equals to a, q value b plus p value again a plus b equals to 0. Okay. Now we have to solve for b, so that you can observe that in these two we can write we can take a common, so that we get a taking outside we get b plus 1 plus b. Okay, or do one thing, we will take b only common from this one. So on taking b common we get a plus 1. So plus a as it is equals to 0. We can solve in the both ways. Okay, so that here we get b into a plus 1 is equals to, we can write minus a, or b is equals to minus a divided by a plus 1 or 1 plus a. Substitute in equation 2 to get the complete solution. Okay, the solution is z is equals to ax plus b value is minus a divided by 1 plus a into y plus c, or further it can be written as z into ax plus, so this minus sign is multiplied to the denominator, so that we get numerator will be plus, denominator minus 1 minus a, so that we can write, so this can be written as a minus 1, or else simply we can multiply this plus sign with minus sign with this plus, so that we get minus a divided by 1 plus a into y plus c. So this is the required solution. Okay, next one, that is next problem, solve p square plus q square equals to m square. Okay, solution. So let us consider given equation as equation 1. Now let the solution of this above equation as z is equals to ax plus by plus c as equation 2. Now replacing p by a and q by b we get, that is in the equation 1 we get a square plus b square equals to m square. Further simplifying, that is solving for b, we get b square equals to m square minus a square, or b is equals to square root of m square minus a square. Okay, so put this value in the equation 2. So thus the complete solution will be is z is equals to ax plus b value is square root of m square minus a square into y plus c. So this is the final answer. Next example, p plus q is equals to p into q. So this is the light, that is slightly different problem. Okay, so here it is given that p plus q equals to p and q. Both the RHS side and LHS side contains p and q terms. So we group one side, that is we take this RHS terms to the LHS sides. Solution. Given equation can be written as p plus q divided by pq equals to 1. So further it can be simplified as p, so dividing by this p we get p get cancels, we get 1 by q plus q get cancels, we get 1 by p equals to 1. Now consider this as equation 1. Now let the solution be z is equals to ax plus by plus c. So consider this as equation 2. Now replace p by a and q by p in the equation 1. so that we get, or simply here you can consider this one as equation 1, so that the simplification will be easy, or you can substitute directly in this also. Okay, so now we get, here we substitute in this only, so better you consider this as equation 1. Okay, or else you can substitute here itself. Okay, we substitute simply in the equation 1 only, so we get 1 by a plus 1 by b equals to 1. Okay, now 1 by b value is equals to 1 minus 1 by a. So taking LCM we get a, that is taking a as the LCM we get a minus 1. So that b value will be, so here we have got 1 by b value is equals to a minus 1 divided by a. So taking reciprocal we get b is equals to a divided by a minus 1. Now substitute this value in equation 2, so that we get the complete solution. Thus the complete solution is z is equals to ax plus b value is a divided by a minus 1 into y plus c. So this is the required answer. So like this you can solve type 1 problems. Okay, so now type 2, that is non-linear PDE of type 2 will be continued in the next class, that is next video.